In this experiment, the control area network is shown as a transmitter. We'll first build the program, then we'll debug it. Now, we'll enter the main function and set the clock at 60 megahertz. The A to D converter is used, which is set at 10 bit at channel 0, 3 megahertz. And we'll start the A to D conversion. We'll use pin select to enable pin 25 of port 0 to behave as a receiver for CAN, and we'll set CAN controller into the reset mode, after which we'll set the bit timing to 125 kilobits per second and release the CAN controller. We'll next enter a function in which we'll initialize the CAN controller. Now in the called function, these are the statements of the called function. Here we'll set all ports to output by using IODIR1 register and enable pin 25 of port 0 to act as CAN1 receiver. Next we'll set CAN controller into the reset mode, after which we'll set bit timing to 125 kilobits per second and enable the receiver out interrupt. We'll now select a priority slot for a given interrupt and pass the address of the IRQ into the VIC slot to enable the interrupt. We'll then disable the acceptance filters to allow step up of the table and execute all the functions in initialized called function. We'll now enter the do while loop in which the data register value of A to D converter is copied into variable val, and if there is some valid value, the transmission takes place. For the transmission bit is checked, which is in the register C2SR, by using if statement as shown. If it is satisfied, it enters into the if loop, in which we'll copy the analog to digital conversion result into the first 4 bytes of C2T DA1 and transmit the message by using C2 CMR. We'll now run the program. After the complete execution, it is found that there are 3 communications happening here. Now the output pins are cleared, and then we set the output pins, release the receive buffer and signal the end of the interrupt. Thus the interrupt routine is completed.